laws of indices. Basically, every question related to indice or exponential function will be solved by using get 2a cube divided by 3a square times 6 into the power 5 logarithm. So, what are logarithms and how do they relate to exponents? Alright, properties of logarithms. Right, now before this, I'm going to write down the properties of exponents. Welcome everyone, welcome to today's class. In this class, we are going to start off with logarithmic and exponential functions. So this is the class 2, and as you all know, in the previous class, we did exponential and logarithmic functions with their properties along with some of our examples. So today, we are going to study the graphs of logarithmic and exponential functions. So let's begin. So the first thing is graph of exponential functions. I have taken two conditions here. You can see on my right and on my left, right? Two different graphs, two different conditions. So the first graph on my right is the graph of y equals a to the power x when a is greater than 0. So basically take it like this: y equals 2 to the power x, something like this. Although not an exact graph, right? But just as a example, I have given you this graph. All right, so the graph of y equals 2 to the power x would look something like this, where x equals to 0, y equals to 0 or x-axis is your asymptote. Now what is an asymptote? Asymptote is a value from which line appears to touch but never does, right? So if you'll notice this yellow line, right, this yellow line appears to like come closer and closer to the x-axis, but in reality it never touches the x-axis, right? Because if it touches the x-axis, then y has to be 0, and this y can never be 0 for an exponential function. All right, so that is why x equals to 0, y equals to 0 or the x-axis is an asymptote for this function. All right, next, if my a is less than 0, an example is y equals minus 2 to the power x. All right, there's a difference between this and this. All right, do not take them as the same thing. Y equals minus 2 to the power x and y equals minus 2 raised to the power x. All right, are they the same thing? Sorry, basically this is not there, right? So we'll be only drawing graphs of minus 2 to the power x. There is no need for the y equals minus 2 to the power x, right? So this is the graph of minus 2 raised to the power x. Basically, whenever we are drawing the graph of, okay, we'll be dealing that with later on, so that not right now, just copy these two down. All right, let's move on to these notes. That's what I was talking about, that's what I was going to tell you in the previous slide, but let's read it right now. Okay, to find the graph of y equals f of minus x, take the reflection of fx graph in y axis. All right, basically if I have to find the graph of f of minus x, basically if I'll change or replace x with minus x, I'll be basically taking the reflection of the graph in y-axis. All right, to find the graph of f inverse x, take reflection of fx in the line y equals to x. So basically if I have the graph of fx, right, and I need to find the graph of f inverse x. And what I need to do is I need to take the reflection of that graph in the line y equals to x. Alright, last, to find the graph of y equals to minus fx, take the reflection of fx graph in x-axis, and that was the case in the previous slide, right? That was minus a to the power x, right? Not minus a, sorry, minus 2. That's the graph I drew, and if you'll notice, the graph on my right, that is in yellow, and the graph in the pink, they are basically reflection of each other in the line y equals to 0 or x-axis. Alright, so if you'll take the reflection in x-axis for the graph, this one, you'll get the graph of y equals minus 2 raised to the power x. So please make sure you remember these 3 points, very carefully. If you have to find the graph of f of minus x, take the reflection in y-axis. If you have to find the graph of minus fx, take the reflection in x-axis. And if you have to find the graph of f inverse x, take the reflection in y equals to x. Alright, please note it down. Alright, let's move on to the next one. On the same axis, sketch the graph of y equals 3 raised to the power x, y equals 2 raised to the power x, and y equals 1.5 raised to the power x. So basically, whenever you need to find the graph of y equals to a to the power x, when a is greater than 0, right? So your graph needs to be something like this, correct? Now, how do we differentiate when all the a's are positive but have different values, right? Now, make this point in this condition when a is greater than 0. Right, this is my main and the important term for this question. If my graph is y equals a to the power x when a is greater than 0, and I need to plot 2-3 graphs on the same axis where a has a different value. So what I'll do is the graph of the one which has the greatest value of a will be the steepest, and the graph of the one which has the lowest value of a will be the least steepest, and the one in the middle will be in the middle. All right, so if I'll draw the graphs, obviously I'm not going to draw the actual graphs, just a rough idea. So I'm going to draw this one with green color. So let this be 1, right? Okay, so the graph will be something like this for y equals 3 to the power x, right? For 2 to the power x, it will be something like this, right? And for this one, 1.5, the graph will be something like this. Let me remind you that the graph of all of these will pass through a common point, that is y equals to 1, or when x is 0, t to the power 0 is 1, right? Here 2 to the power 0 is 1 and 1.5 to the power 0 is also 1. So at x equals to 0, all the graphs are going to intersect the y-axis at 1 always. So the point of intersection is this. There is not going to be any other point of intersection. So the graphs might be a bit up and low to the left, but actually that won't matter. The main important part is the right part, right? So this is the graph of 3 to the power x. right? See, decreasing order of A. That's the order of the graphs also. All right. So please note it down and make sure you're writing this point down. All right. Next one. On another set of axes, sketch the graph of. All right. But before we do that, let me just, like switch them up. If I do the reciprocal of this, what will I get? 2 to the power minus x, and this is the graph of y equals 2 to the power x. See, if this is the graph of f of x, isn't this f of minus x? Yes. And what was the condition when we had to draw the graph of f of minus x? Just take the reflection in y axis. Very good. So let's draw the graph of 2 to the power x first. The graph will look something like this, obviously, right? Now I need to draw the graph of 2 to the power minus x, and that should look something like, if I'll take the reflection of this graph along this axis, right? So basically I need to take the reflection in this line, right? This yellow line. So I'll be getting something like, yeah, this thing, right? Check it out. You'll see that yes, this is the exact reflection of each other. The pink graph is the reflection of the green graph exactly in the line y axis. All right. Okay. So please note it down. Also remember, the question could have asked you to draw the graph of minus 2 to the power x also, right? So this is the graph of minus fx. And what to do when we have to find the graph of minus fx? We take reflection in what? Reflection in x-axis. All right, everyone. Okay, let's move on now. Okay, so graph of logarithmic functions. Although we don't deal with logarithmic functions much, but all the conditions of what we studied for exponential functions will be the same for logarithmic functions also. So the graph of a logarithmic functions is something like this. All right, hold on. Yeah, something like this, where the graph passes from x equals to 1. All right. Now, how did we derive this question, or how did we derive this value? We can take this also. If y equals a to the power x, then graph of x equals log y base a is inverse of y equals a to the power x. All right. So basically, if this is my function fx, this is my function f inverse x, right? So what was the rule to find the f inverse x? To take the reflection in x axis, y equals to x, sorry. So the graph of this function was something like this, right? And my see, they do look like the reflection of each other, right? Both the green lines are reflection of each other. So that proves the theorem and the identity also, that if you draw the graph of fx and take its reflection in the line y equals to x, you get the graph of to get the graph of f inverse x. Alright everyone. Okay, so please note it down. Alright, moving on to the last question, and the question is, a brand of invisible ink fades rapidly once it is applied to paper. Fine enough. After each minute, the intensity is reduced by 1/4. So after each minute, the intensity is reduced by 1/4. So how much is remaining? 3/4, obviously. So if let's say I have $100, I spent 1/4. So how much do I have with me? 3/4. All right. So I can write ink remaining is what? That is basically ink remaining is like 3/4 of total, right? So after 3 minutes, what is the ink remaining? Ink remaining will be equals to 3/4 raised to the power t. All right, and that is 5%. So 5%, hold on, it becomes unreadable to the naked eye when the intensity falls below 5%. So 3/4 raised to the power t is less than 5%, that is 5/100. All right, or you can write this as 0.05. Correct. So that is okay, let's apply log on both sides. So I'll get t log 0.75 is less than log 0.05. Now what do people mess up here is, they take this log 0.75 and they will write t is less than log 0.05 divided by log 0.75 like this. But here's the mistake. Okay, I didn't tell you this, but I'm going to tell you right now. Log 1 was 0, right? So any number which is less than 1 will give you a negative log. Basically, if you deal with log 1/2 or log 0.5, that will give you the answer as minus 0.141, something like that, right? Okay, so I can say for sure that I'm not sure this is correct, but fine, something like this, right? You'll get a negative answer for sure. All right, so I can say for sure that any number which is less than 1 will give me a negative log right now. Okay, so in this step, this number would have been negative, right? And whenever we take a negative number in the cross multiplication, we always change the sign. So rather than this, my answer should have been this, right? And that is the mistake that most students do. So what we are going to do is, we are not going to do this step first. Rather than this, we'll be finding the value of log 0.75 and log 0.05, right? And then we will divide and change the sign at the same time, right? I hope you can do it, and you will be getting t is greater than log 0.05 divided by log 0.75. On solving these values, you'll get a decimal answer, and take the greater value than that and you'll find your perfect answer. All right, so that's it. Please note it down. All right everyone, so that's the end of this class, and I hope the graphs of exponential and logarithmic functions are clear to you. So we'll be meeting in our next class with another video. Till then, stay safe and keep practicing. But before we go, please do not forget to like, share and subscribe to our channel. Thank you. If you had a blast watching, give us a thumbs up, share it with your friends and subscribe our channel to stay updated on all our future videos.